All right, everyone. Today we are going to look at the distributive property. Now, the distributive property is actually a way to break the order of operations. And typically, it'll end up looking something like this initially, right? You've got something outside of parentheses, and you've got addition or perhaps subtraction inside of your parentheses, and you're trying to figure out how to break it. Because for whatever reason, maybe you can't do the addition or subtraction that's inside parentheses, but you'd like to still be able to carry out the multiplication. The way I like to think of this property is with a visual. So I'm going to create this area problem, okay, where I've got two rectangles together. Both of them have a height of A. One's got a width of B. One has a width of C. Okay. And the way I like to think about the distributive property is there are two ways to figure out the area of that figure. One is to add B and C together first to figure out the length of the whole rectangle, right? And then multiply by A, right? That's really what this says over here. This says add B and C first, and then after that, multiply by A. What the distributive property does, though, is it takes advantage of the fact that there's another way to figure out the area here. The other way to figure out the area, say, well, this small rectangle has an area of A times B. This other small rectangle has an area of A times C. I can figure out those areas individually and then add those areas together. So basically, I can get AB, or A times B, plus A times C. This amounts to what the distributive property is. Oftentimes you'll see folks kind of go like this to show that you can distribute that multiplication. You can give that multiplication to both B and C. But I like this visual as an idea for why it works. You could add B and C first, or you could figure out the two little areas and then add them together. Okay. It's important to see this rule in action to see why in algebra we kind of need it a little bit. So this first one is a great example. We cannot add 2x and 3 together, even though they're in parentheses, and we should do that first. We can't add them together because they're not like terms. So what we'll do instead is we will do the distributive property. We will do 3 times 2x, which is 6x, and we will do 3 times 3, which is 9. We were able to simplify the expression by using the distributive property. B all by yourself, and then come back. Okay, I'm assuming you've done that. Hopefully what you got is 8x, 2 times 4x, plus 10, 2 times 5. Now, when variables come into play, sometimes this causes problems, but really not too often. It just kind of makes the multiplication a little bit trickier. What we basically need to know is when we're multiplying x times x, what do we get? Well, that's where exponents come in. X times x is x squared, so when we're multiplying 2x times 3x, we get 6x squared. When we're multiplying 2x times 4, we get 8x. And that subtraction sign is going to stay. Okay? Try B, and then come back. All right, I'm assuming you've done that. Hopefully you got 20x squared, 4 times 5, and then x times x is x squared, plus 8x. 4 times 2 is 8, and then I've got to keep that x on there. Now, moving forward, subtraction is another thing that can cause a little bit of a wrench in our plans here. So for this first one, what a lot of people will attempt to do first is they'll attempt to do 3 minus 2 first. But that's not order of operations, right? Order of operations actually says we should do the parentheses first. We can't do that, but the next step in order of operations is multiplication, and that 2 is being multiplied by the parentheses. Okay. However, what we need to be careful of is because there's subtraction here, we kind of have to decide, are we distributing a 2 or are we distributing a negative 2? Well, we're actually going to distribute negative 2 because if you were to change that subtraction to addition, it'd be pretty clear that you're distributing a negative 2 here, okay? So anytime you see subtraction before the parentheses, you are distributing the negative sign as well. So I'm going to keep my 3. Then negative 2 times 2 is negative 4. And where we really got to be careful is right at the end here. We're actually doing negative 2 times negative 2x because we want to include that negative with the 2x as well. So we're going to get positive 4x. Then what we should be doing is seeing if there's any subtraction that we can do. Well, as it turns out, now there is, because now we're not limited by the order of operations. This is all addition and subtraction. We can combine 3 and negative 4 to be negative 1. We get negative 1 plus 4x. Once again, try B, and then come back. All right, I'm assuming you've done that. You should get 4 minus 6x minus 12 after the distributive property. Again, keeping in mind you're distributing the negative. And then we can combine the 4 and the minus 12 to get negative 8. So we get negative 8 minus 6x. Last but not least with the distributive property is division. Turns out you can do the distributive property with division as well. This fraction bar acts very much like what we call a symbol of inclusion. So it essentially puts the numerator in parentheses. And then what we're going to do is instead of multiplying everything by 2, because the fraction bar means division, we're going to divide everything by 2. So 2 divided by 2 is 1. So we just get x. 4 divided by 2 is 2. So we get 2y, and negative 6 divided by 2 gives us our negative 3. Over here, we're going to get x. Oops, sorry. Pause, and then come back, and then I'll reveal that answer. All right, so 4 divided by 4 is 1, so we get x. 8 divided by 4 is 2, so we get 2y. Last one's a little bit tricky. But you can do 2 divided by 4, and you can just get 1/2, or you can get 0.5 if you wish. 0.5z, I guess I'd write, or 1/2 z. There's other ways to simplify that expression, but if in terms of the distributive property, that one works pretty well. Hopefully this was helpful for